Okay, this picture on the right over here gives an indication of what's happening. This is the graph right here of y equals x squared, just the right half of it, which, depending on the method that you're going to use to find the volume of revolution, you could also write as x equals the square root of y, where y is a positive number. And similarly, this is the graph of y equals the square root of x, which you could also write as x equals y squared. But y has to be greater than 0 because we're taking the square root of a positive number. Here's what that solid of revolution looks like. And here's how you find the points of intersection of the two graphs. And those points are labeled 0, 0, and 1, 1. And you have to make a decision whether to use the shell method or the washer method. If you use the shell method, your typical shell wall is parallel to the axis of revolution, which is this line x equals -1. And if you use the shell method, you also need to have an expression for the average radius, which is the distance from the center of the shell to the axis of revolution. If you use the washer method, your typical washer, well, you need an outer radius, which would be this distance, and you need an inner radius, which would be this distance. And then the formulas are different depending on which method you're going to use. So here's what the shell method looks like. Here's your typical shell wall. And we need the height of the shell, which is for every x between 0 and this 1 right here, the y coordinate of this point at the top is square root of x, or x to the 1/2. And the y coordinate of that point at the bottom of the shell is x squared. And so the height of that shell can be represented by the y coordinate at the top minus the y coordinate at the bottom. So there's an expression for the height of a shell. And the average radius is the distance from the axis of revolution, which is x equals -1, to the center of the shell. Well, this distance right here is x. So the red segment here is the x coordinate at the right, which is just x, minus the x coordinate at the left, or x plus 1, or this distance is x, and this distance is 1 is another way to think about it. So x plus 1. So there's your height of the shell. There's your average radius. We're integrating from 0 to 1 because that's where the shell walls appear, between this 0 and this 1. And then there's the multiplication of 2 pi. And if you multiply these two binomials together using FOIL, find an antiderivative, evaluate from 0 to 1, multiply by 2 pi, there's an exact value, 29 pi over 30. And if you want to use the washer method, now you need an outer radius and an inner radius. So the outer radius is the length of this black segment here. It's a typical washer. And for every y between 0 and this 1 right here, the x coordinate is y to the 1/2, or the square root of y. So the length of that black segment is y to the 1/2 minus a -1, or y to the 1/2 plus 1. There's the outer radius. There's the outer radius squared. Inner radius follows a similar pattern. The length of that green segment, y squared plus 1. Inner radius squared. If you square this binomial, combine similar terms, find an antiderivative, evaluate from 0 to 1, multiply by pi, you'll get the same answer. Okay, there you go. Hope that helped. If you have any questions, post a comment.